In lesson 6.1, we talked about the normal distribution. And one of the properties of normal distributions is that the area under the whole thing is equal to 1. So we can use that information to start looking at some probability situations. So there are lots of different distributions that are approximately normal. And one of the things that's important as far as applications is that the area under any part of the normal curve is equal to the probability of having a variable fall in that region. Okay, so more specifically, if we want to talk about this, the area of the normal curve to the left of a specific value is the probability that our random variable x is less than whatever that number is. And the area under a normal curve to the right of a specific value is the probability that that random value is greater than this value. So let's actually draw some of these out and kind of think through them. So we have the weight of adult Labrador retrievers seen in an animal clinic is 75 pounds with a standard deviation of 5 pounds, and it's approximately normally distributed. So I'm just going to sketch that out real quick. Maybe. Pencil here. There we go. All right, so normal distribution here. We want to know the probability that an adult Labrador retriever chosen at random from the clinic weighs less than 80 pounds. And we're going to use tables to do this. So I'll show you that in a minute. So in order to use our normal distribution, we need a z-score for this. So z-score is x minus mu over sigma. So let's see. The x value that we're looking at is 80 pounds. So we have 80 minus mu is 75. And our standard deviation sigma is 5. So we get a z-score of 1. Okay, so on our standard normal distribution, remember here's 0, so 1's going to be up here. What we're trying to find is the probability that a dog chosen at random from the clinic is less than 80 pounds. Now, since that 80 pounds corresponded to a z-score of 1, we are trying to find the probability that we have a dog that is less than 1 standard deviation above the mean. Okay, so here's 1, and we want to find the probability. We want to find the area under the curve to the left of that, because that's going to be our probability. So we have several different ways that we can do this. The first way I want to show you is table A and B. These are in your textbook, but they're also on the yellow paper with all of your formulas on it. So that's actually where I'm going to go for these. Let's see. So we're looking for the probability that x is less than 1. So on your yellow paper, you have your first table. Once you get through all the formulas, there's table A, standard normal distributions. And notice over here in this left-hand column are your z-scores. Now, all of these z-scores are negative. So this is not the page we need. We need the next page, which is table B. And notice it says right here, it's the probability that a standard normal random variable is between negative infinity and z. So this table is telling us the area to the left, and it shows that in this little picture at the top of the page, the area to the left of z. So our z value that we're looking at is 1. So over here on the left-hand column, you're going to go down to 1, 1.0, and then the hundreds place, that's where you look up here. So we're looking at 1.00, which is right here. 0.8413. And that is going to be our answer. So over here, the probability is we need a pencil, sorry. 0.8413. Okay. So the probability that a randomly chosen Labrador retriever chosen from this clinic, the probability that they are less than 80 pounds, that they are in the shaded region, is about 84%. Let's do another one. We want to find the area under the standard normal curve to the left of z equals 1.37. And again, we're going to use a table. Always draw these. It's definitely best. So here's your normal distribution. 1.37 is going to be somewhere up here. We don't have to be real specific. And we want to find the area to the left of that. Remember, that's 1.37. I will write that in there. So we are trying to find the probability that we are less than 1.37 to the left of. So we're going to go back to that table. So that yellow sheet of paper, again, we're on table B because we have 1.37. So the z-value that we're looking at is 1.3. So you come down here to 1.3 and then across the table to 7. So it looks like right here, 0.9147. So over here, we're going to write down 0.9147. So the probability that a randomly selected variable from this falls in the shaded region is about 91%, which makes sense. I mean, we've shaded in a whole bunch of this. Now, we don't have to use the table. Our calculators also do this. So I'm going to show you how to find these on the calculator. Desmos does it too, so just in case you don't have your calculator, but I'm not going to show you that, just I think because you all do have calculators with you. So we want to find the area under the standard normal curve to the left of z equals negative 0.203. Now, I'm still going to draw this for you. Always a good idea to draw it. So here's our normal distribution. Now, negative 2.03, that's like way down here. And we want to find the area to the left of that. Okay, so just from our drawing, we can see that this is going to be a small number. So now we need to go to the calculator. We could go to the table and look it up just like we did in the last problem. But we're going to go to our calculator. And you're going to go to your distribution menu. Remember, that's where the binomial distribution was. So second distribution. This is not binomial. This is a normal distribution. So we are going to normal CDF. Okay, we're always going to use CDF when we use normal distributions. Now, my calculator that I'm using on my computer is a little bit older version. Yours, when you get to this page, it's going to say lower, upper, mu, and sigma. Okay, I'm just going to type those same things in order. So if you have an older calculator, this is what it's going to look like. So remember, we are looking for area to the left of. Let me get back to this picture so you can see it. Okay, our lower bound down here is negative infinity. So we need to type that in. The way we do that in the calculator is we do -1, and then we want to use scientific notation. There's this double E button right here above the comma. That's scientific notation. So to the 9 to 99. Okay, so that's basically scientific notation for negative infinity. That's about as good as we can get on this calculator. So that's what you're going to put for your lower bound. And then on your calculator, just go down to upper bound. If you have an older calculator like mine, hit comma. Our upper bound is going to be this boundary, which in this problem was negative 2.03. So your upper bound is negative 2.03. Comma for me, you just have to go down to mu. We're on the standard normal distribution, so mu is going to be 0 and sigma is going to be 1. Okay, and on your calculator, you'll hit paste and then it'll pop up and it'll say the exact same thing that mine does right now. And then we're both going to hit enter and we get 0.0212 when we round it. Okay, we always round these to 4 decimal places. So back on our problem. So we were looking for the area to the left of negative 0.203, and we got 0.0212 when we rounded. And like we said, remember, we knew that that was going to be a small number because that's a very small area that's shaded. All right, we'll do one more and then we'll switch to a different video. This time we want to find the area under the standard normal curve to the right of 1.37. And we're going to use tables for this. We're going to bounce back and forth between tables and the calculator. So again, graph this. 1.37 is somewhere up here. Go ahead and write it in. This time we want the area to the right. Okay, that's what we want. Now, our table, we want to find the probability that x is greater than 1.37. Okay, the area to the right of that. Now, if you remember our table, it only has areas to the left of. Okay, so if we use our table, it's going to give us this area over here. Well, remember that those areas are going to add up to 1. So what we'll do instead is we can still use a table. We're going to do 1 minus the area to the left of, because we can only do area to the left of on the table. So 1 minus, and now let's go look at the table. So we have 1.37. So again, we have positive z-value, so we're on table B, going to 1.3, and then over to 0.07, so 0.9147. That's what we want. 0.9147. And then when we subtract from 1, we should get 0.0853. And that is this area shaded here in blue.